Good evening, ladies and gentlemen. My name is Mike Mannion. I'm one of the Vice Principals at Glasgow Caledonian University. It's my great pleasure to welcome you here this evening for the latest in our series of inaugural professorial lectures. This sort of event, this sort of public engagement, the opportunity to discuss, debate, share ideas with each other in a safe space is integral to our role in society as a university. The inaugural professorial lecture is an occasion of great significance for the academic, and it is here to mark and celebrate the achievements of the career to date, but also a great opportunity also to showcase ideas with friends, colleagues, family. Have they turned up yet?
Yes,
oh, they great. With funders, with beneficiaries, and of course the general public. Tonight we're here to introduce Professor Tuleen Boutaleb, who is Professor of Telecommunications and Electronic Engineering. And for those of you who don't know, but Tuleen has served the university in a number of different roles in her career, as a researcher, as a lecturer, as a head of department, as an associate dean, and now recently appointed as vice dean. But she's also been one of the driving forces for the uptake of science, technology, engineering and mathematics education, both to pupils and schools, to their teachers, to parents, really encouraging them about the value of those disciplines and the great variety of careers that one can have if one studies those subjects. That's not all she's done. She's also been the chair of the Tackling Racism Group, which is enormously important work for us as a university. And she's led that group extremely well. And it's given a lot of advice to us as a community and the senior managers who have run the university around changes that we need to make both to structural issues and personal behavioural issues as we strive to weed out all forms of behaviour and systems that constitute racism. But tonight she's going to talk to us about smart systems and in particular the role that communications play in the reliability of those systems, and drawing upon some examples that she has been involved with personally herself in her career. So, ladies and gentlemen, if you would put your hands together and give a round of applause.
And thank you to everyone. Thanks a lot for your time, for attending. Really appreciate it. So, as Mike, did you mention exactly what's my subject area?
Telecoms and electronics, is that okay?
That's the one, yes. So, my first question is to all, any telecoms engineers here? Hands up, any telecommunications? Oh, don't be scared, don't be shy. No one is going to ask you something to work on, something that is not working in the telecoms. We always get blamed, so be proud. Telecoms engineering is an amazing, amazing subject area. I would challenge anyone who doesn't agree with this, just try a day without it. Yep, just try one day without it and tell me then it's definitely the best subject area. So, basic presentation, content. I'm hoping to first just give you a bit on my journey, really journey you'll see from the start a bit into university, and then research over the years. I'm just really going to focus a bit, just really on any research that I've worked, and especially from the start, anything that I've led, obviously, was in numerous other research projects, but that will be the focus. And then a bit more project examples, just really to get the idea of a smart everything eventually. And then, as Mike mentioned, you know, for my colleagues, my friends that know my passion, you know, with ADI and especially ADI and STEM, I'm just going to touch on it depending on time, and then obviously Q&A at the end. So, as I've mentioned, we're starting from the beginning. So hopefully if you can follow as the red kind of circles appear. Was born in Tripoli in Libya, and that was back in 1971, so quite a long time from now. Moved to a small town I can see some international students here. It's called Helensburgh. It's like about 45 minutes from here. When I was a few months old, you'll see a lot of jumping around because my dad had traveled a lot at the time. Then went to Damascus in Syria, so that's where my parents were born and you know, lived there. You can see at this age, I'm telling you, the telecoms scene has already developed some interest in telecommunications at that age. And you can see the puzzled face. Why is it not working? Why is the comms not working? And then after that, to Kuwait, to Saudi Arabia, Dubai. And Dubai at the time when it had one building, so not what you're familiar with, but I'm serious, I went as the building, that was my school at that time. By that time, I have experienced the American system, British system, Arabic system in education. It was like absolutely bad, but obviously very enriching as well. Then went back to Saudi Arabia, all over here, so between East, Middle, West, and that was as well, you know, took a number of years, 10 years. Then Algiers, and that's where I started high school. And high school was very specific there. It was, I had to introduce another system, was the French system, but in Arabic. Which meant 3 years to the baccalaureate, and it was all in mathematics. I always wanted to be a vet, I wanted to be a scientist, but I was good in math. In Algeria they said, no, you need to be in mathematics, that's what is needed. So did mathematics, then moved to Morocco, in a small town called Tétouan. And that was a French system in French. I didn't speak a word of French, so I failed. I failed my baccalaureate. I went back to Algeria, do it in Arabic. So for anyone who either thinking about, oh, I'm either going to fail or not, it doesn't matter, you'll pick up and you'll do well at the end. So went back, got my baccalaureate, and just to say for everyone that doesn't know, baccalaureate is really, really hard, and at that time it was very, very hard. It was a pass rate of 12%, so I was a genius. I did pass it at that time. I don't know. So, and then I got an offer to be in microelectronics engineering, but that was in Algiers. My brother, who at the time and still does live in Helensburgh, he said, how about you do the program in here, you know, why don't you come and do it in the UK? So I thought, okay, that's fine, and you'll see next that journey. Obviously can't really continue without thanking a lot of people, and I mean a lot. I can see here a number of colleagues, which, you know, I'll come to that, but initially it has to be my family. So, mom and dad, my two, I was going to say annoying, but amazing brothers. And then my two daughters who are right there, my husband who's working tonight, so he couldn't come. So obviously, you know, they've been all amazing and supportive throughout the years. So here's the university journey. So as I've mentioned, I accepted, came to the UK. Didn't speak English at the time. My daughters would say still, I don't speak English well, but I'll try my best. best. And I learned for 1 year English language, and then basically started electronic engineering, started here. And you can see it was proper kind of hands-on labs and engineering stuff. And you can see as well my dedication even to cleaning as well, you know, within that was our time, you know, student union. And some staff as well from quite, I know, retired now, some would recognize, I think. Who is that? And that was a graduation. So finished after, you know, 4 years, graduated, and I thought, okay, that's me, done my education. I went back to Algeria, got married. I thought, that's it. I'm gonna live an easy life and do nothing. I was speaking with my dad and my husband in the summer, so that was summer 1995. I said, oh, by the way, I was offered 2 PhD scholarships, but I just said no. And they were like, what, are you crazy? I was like, yeah, I mean, that's it, I'm just happy just to sit and do nothing. And they said, oh, go back and speak. And one of them said, yeah, it's still available. So I started my first research in European research, and I can see a member of that team, the original team in the audience. So that was my first research project that I worked on. And you still can see the support of the family. My dad there visited me, I can't remember if it was the first week or so, but he visited me the minute I went into the office. And for some who know the building here, it's that one is C141, now it's a materials lab. So a lot of really super good research happened in that room. So I'll start with the idea with the smart, you know, because remember I've said, you know, smart cars, smart cities, smart everything. So really what makes anything smart? If I look in here, again, starting with the telecoms bit, massive connection is obviously here, the one that you can see, which is the wireless connection. I know you're going to say this is an ugly phone, but I'm not going to allow that to happen because that's a Nokia 2110. I know for many it doesn't mean anything, but that was the mobile data revolution, and I really, really mean it. That one was what started what we've got now. I know the data rate, the speed that it used to go at was ridiculous. If I tell you it's 9.6 kilobits per second, you say, what does that mean? We're used to 100 meg minimum. So, but the point is that it was able to get data, and that was really the most important bit. So the project, as you can see in there, it basically had a few street lights. But the way that they became smarter is basically we had a number of sensors on them, sensors looking at the light, would they dim, would they switch on, and then most important is whether they are on during the day when they're not supposed to, what indication that would give us, and basically send some control signal to them in order, for example, to switch them off or identify you know, flickering, identify some faults and so on. So that was really a big deal in there. And I remember we were so excited. We got the hardware for the street lights that goes and connects within the street light lamps. And then the one that you can see there's a node which enables the communication. And then in the lab itself, we had another node that connects and is like the control, if you want, unit. So we're so excited. It's a European project, so it was with Spain, a number of other you know, industrial contacts in other countries. And basically, we switched a light on in Spain. And someone told me, someone who was visiting the lab, he said, is that all? I was like, is that all? Are you kidding me? And from the UK to Spain. So it was a massive thing. So a number of things in here, just again to highlight, because I can see some of students who are in telecoms, electronics in there, so hopefully you're all very aware of the wireless communication. But for some who are not aware, you've seen hopefully some masts around, so you know that it's part of the mobile network, and that becomes important later on. So other projects, for example, flood early warning system. Again, you'll see that keeps coming up more and more, where I'll have a number of wireless communication. You'll see that there is some smartness in the nodes. So that was a project, initially SEPA was the one that basically said there is a requirement, we've got areas that they have like one expensive detection basically was worth 100,000. We want to go low cost, and we want to be able to detect any warnings, early warnings of what's happening with the river. So we had a number of sensors in there, so you can see rain, water, flow rate, moisture, temperature, and so on. And it was all one node in there, and obviously you can see the antenna in order to communicate back to a gateway. The idea was to place these nodes in side of the rivers and all the sensors beside, so that means you can get all the data back and be able to see what's happening in there. Whether there are, any changes, whether there's going to be an imminent, for example, flood. So again, communication part was obviously a big part of that, and in here was the Things network that we've used with the data gathering. The smart city system modeling was another project, and in that one it was, you can see the whole city would have smart mobility, smart people, environment, living, economy, government, a number of areas in there that will eventually make the full city as a smart city. The focus in that particular project was really to model what a city with these kind of elements to it would be, and then test it across a number of different parameters and focus on one of the areas. So one of the focus was really in the smart mobility. And within that smart mobility, it was mostly really regarding looking at green infrastructure. So deciding for the vehicles which is the best route, not from a point of view of how long it takes in that route, but really how much pollutants from the cars or from the vehicle will be absorbed. So a number of parameters regarding the trees, type of trees, how much they would absorb would be in there, but basically it will dictate which route, so you'd have a number of options in there. So that was another project also worked on. I'll focus a little bit on this because there are a number of things, and because obviously engineers would always love to analyze some data, so there is a few of these that I'll be looking at in a minute. But vehicle-to-vehicle infrastructure comms, so for anyone here, mostly for academics, that they are thinking with bids and grants, we originally, that came across from a European funding, so it was a Horizon 2020 fund, it was a call, it was quite a big project, had across Europe, partners of industry, same idea with any of the European project calls, and it was around 8 million. It had 2 phases. We were successful in phase 1, but not phase 2, but from that came a research fellow, a research PhD student, and an intern as well. So it was really good at the end, that you've got a number of projects that came from that. And if you've seen so far is the applications, you can, with comms and with anything becoming smart, you can have the fun side of it. You can have a number of areas that you're looking more for the society change, or you're looking from, the technology part. For me so far, I don't know if you've started, forming the theme. So with the street lights, the safety bit is really, really important. For the early, flood warning system, again, the importance there to try and get as much as possible early warnings to people. And here with the vehicle infrastructure, one of the things is really more into safety. So how much can you, avoid collision, for example? How much efficiency when we talk about the pollutants? So I know we're moving into electric cars, but at the moment we still have, petrol-based cars. So it is still obviously an issue, so you want to minimize the amount of time that these vehicles stay on the roads. So with that particular project, the safety was really a massive thing. So what you can see in here is that we've got the vehicles communicating. When we talk about infrastructure, these are the masts that you have seen in the original slide when I was talking about the Nokia communicating with the mast. So you can see mostly in here what we've got are the cars, the vehicles that are communicating with the infrastructure. So really everything is going via the mobile network itself. We added a server, so that server is really for the vehicle safety applications. And if you think of different scenarios, so you'll have an urban scenario, so right in the city center, the kind of accidents that will happen would be different from the ones on the motorway, from the ones in the rural area. And what I mean by that, at the end of the day, it's a vehicle that will crash, for example, into something at the close of it. So if you look into urban, you're not going to have high-speed, vehicle. It's mostly the case that someone went through a red light, for example. They didn't see each other at intersections and things like that. And that will be different if it is motorway, which is mostly high-speed, lane change, and obviously rural area, it might be more of a head-on collision. So from that, what we did is like a table with an index of, and that's what this server would keep and compare the messages to, where the index will indicate all the relationship parameters of that particular potential accident and then prioritize it. There is a priority with regards to the timing. Obviously, every single accident to avoid is really the target, but there are certain ones that they really need much more, the timing, the delay has to be the minimum. So with that in mind, with the vehicle safety application, if you look in here, so the red one was without our algorithm. The target is 100 millisecond end-to-end delay, so end-to-end is really from vehicle all the way to the vehicle of interest. And then what you're looking at is the probability. So we've got there the cumulative distribution function in there, and the probability of the delay to be less than 100 milliseconds with our algorithm, no matter what the parameters, is really above 95% that you'll get below 100 milliseconds, where without, you're looking at around 70%. And I know many will not be impressed with 95%. They will tell me what happened to the 5%. I know there is always room for improvement in everything that we do, but at least it's better than the initial 70%. So that was really the start of that particular project, and then a number of things that I'll be just briefly mentioning will continue from that. So the next thing you've seen there is that the communication is really with the infrastructure. How about if we communicate with other vehicles? So the idea was really to develop, I tried my best here to remove all the different generations of mobile networks and acronyms, because telecoms and engineers in general just love their acronyms. But that was really more into 4G, 5G, so the fourth generation, fifth generation. It was a combination between mobile network and dedicated short-range communications. And basically, the idea was really two things. One is, if you have a vehicle-to-vehicle communicating, there is a bit on the privacy, a bit on the security side. You know, you're kind of divulging that vehicle to that vehicle, your location, and a number of other parameters. So the thought was, I'll come to that in a second. I said no acronyms, but I'm sorry, it's extremely hard. I'll come back to that in a second, but I'll explain what's happening in here. So if you look, these would be private vehicles. So that's any of us going into a car, basically. So we would call them the low tier. So you've got the low tier nodes here. And then we have high-tier nodes, so you can see a bus, a lorry, a taxi. So these would be called the high-tier nodes. And the idea is that we have got the vehicles of the low tier communicating with any of the high tier that's within range. And it is the high tier that communicates with the infrastructure. So again, the aim is really to get that delay as small as possible. So the one that I originally mentioned, even that 100th of a second is really to get it less. That's number one. But also to see where, for example, the coverage, if we are just depending on the mobile network, then you are loading the traffic as much as there. But if you have a two type of networks, so remember when I mentioned earlier the dedicated short-range comms and the mobile network, so you have both, that means you can offload some of the traffic, some of all these messages from the mobile network to the dedicated one, when, because it's short range, when it's possible for the cars to communicate with each other. So that's basically what happened in here, is that all the messages can go to the infrastructure, but as long as there is within range, you can see that they can communicate directly with any other vehicles that they are from the high tier node. So again, with any of these is, what's the most important thing we said? Delay is one of them. Are we going to get successfully the data, the packets transmitted? Are they going to be transmitted in time? All of that is a consideration, plus a number of other things, because this, I'm just giving you here a kind of a snapshot of what happens at that time. But remember, this is very dynamic. Everything is moving. You know, all the buses, all the cars, the vehicles are moving. Where it is at the moment far away from this bus, that bus is moving here. This car can either become closer or further away, depending as well on the speed that they are going at. Everything else is a very changing environment. So that means, although this car at the moment is connected to the taxi, and in a few minutes it might be connected to the bus, it might be connected to the lorry or to that other bus. So there will be so many changes. That again adds more onto the actual network and the messaging that is happening in there. So for that, a number of things here that we have looked at in the simulation. So remember again, this is only the urban scenario. And within that urban scenario, we've looked at the packet delivery ratio, so very important. The more that you lose packets, then you're obviously losing some information, and some of it would be crucial information. So it's important to see any of these results above this 85% of the packet delivery ratio. So if we're looking at everything else, it might be better that it is having the coverage of that short range, but is having a lot of number of switches. So it's always a compromise. So what is the best, what's the best outcome from here? For us, the best outcome is the packet delivery ratio, even if we're going to get more switches. And that indicates these two green, which whether you have 15 high tier nodes, so these are the buses, taxis and so on, whether it's 15 or 10, most important thing is the range. So although we will have more number of switches, so if you look at that green one, it's above 3, but it's delivering better when it comes to the packets and when it comes to that delivery, successfully delivering the actual packets. So that was one important bit. And then the last one in here, in that particular example, is really comparing what we have done to what's existing algorithms. And again, what you see, if we are looking at how many switches have been done, then these two are our results. So they have got less switches, which is what you want. Less switches means that you are not transmitting a lot, because every time you switch, you are, you are actually bombarding the network a bit more. So the two algorithms there that I did show you, that they are related to the safety applications, so all the safety messages. All of these really to improve whether, and I can see a lot here that they would love to be able just to continue driving their cars and no autonomous. I know a lot, whenever I mention autonomous vehicles, not many like that idea. But have you been on the bus in Edinburgh? The autonomous, the first in the world? No? If not, it is, I think it's about a 10. Oh, someone is saying yes. What was the experience? Can I ask?
The bus in Edinburgh?
Yes, the autonomous one.
I've not been on that one.
Oh, right. Okay, we'll try that one then. So, I don't know if I'm going to say it's a bit disappointing or a little bit disappointing when you get onto the autonomous bus, because there is a driver, and the driver is just beside, obviously at the moment. I think it's a tram until 2025. But everything, part of that work and everything else that is done is really to get us to this. I know there is a lot of legislation, and I can see already some not very excited about that concept of autonomous cars, and I know a lot will say, is you're blaming the driver at the moment, but there is also blame when it comes to AI and everything else. Okay, last two examples. How am I doing with time? Am I still okay? Mike is the one that's keeping the time for me there. Smart agriculture system. So again, hopefully by now you see that for us to have that smart system, we need to have sensors, we need to have a communication system, and we need to be transmitting somewhere where we will get the data and how we'll visualize the data and so on. So in here, moisture, temperature, light sensor. You can see the door, so this is for opening, closing. That will be the control transceiver for the pump in case it needs more water, depending on what the moisture sensor would say. And the servo motor, obviously, to open the door if, for example, the temperature gets too high. And that is more focused on polytunnels. So it wasn't like a farm, this was really more focused on an indoor thing. Very again, familiar with the now LTE stands for long-term evolution, so that's the 4th generation, and away from the old Nokia to the new, more embedded-looking 4th generation. And final example in here is the air pollution, so that was with RSA and Air Monitors Company. And that was done by third-year project students, but again, to give you an idea on the smart bit. That's what they have developed. Basically, if you look at anyone who is asthmatic, who young children, pregnant, that they have, that air pollution will impact them. then there could be a way of suggesting an alternative route. And the only way for doing that, well, not the only way, but one of the ways, is really to have a low-cost distributed system. So in that case, what you have seen on the student here, so that is, if you think of hundreds, thousands, within a city center that they have this, they are getting all the data at certain points in the day, then it would be possible to get a better picture of what does the pollution looks at the moment. So if you look at air pollution here, you can go to a map and you can see what it is, but it's really a very specific, the equipment that they have is in one place, so they have the best, more accurate sensors, but it is within that 2 meter, 3 meter range, where if you are looking at a distributed system, so as I am moving, it's sensing here, and so on, so it's building a better picture on the map itself, wherever you're progressing or the people are going with that detector on them. So in here, just really was a very simple couple of sensors, but rather than using what I've been telling you so far about, there's the mobile network or the short range, dedicated short range, it was really more of a long range. So it's called LoRa. It was enabled with a number of different other comms like Wi-Fi, Bluetooth, but LoRa was the one that was selected, and you can see here the idea is depending on what is detected on that route, then an alternative route can be suggested. So I come to the smart everything. So hopefully you've seen a number of different examples there. By now, you know you need sensors, you need some communication, technology in order to carry these, and then eventually something to act on them. But everything that I did show you had a kind of a way, a central, brain somewhere. It's like a central unit or a control unit. For everything to become smarter, and I know when it comes to AI, you wouldn't like to hear a lot about it, but I think it's more now, you really need to accept it. Initially, maybe we need to think of it as assisting us, and at certain points, it really needs to do its job when it comes to more optimizing things, efficiency. So if we look at smart city in everything, smart parking, smart buildings, we've already talked about the vehicles, the smart health. Don't forget the rural areas, because smart cities was at 50%. I'm sure there are more here that can correct me with what's the ratio there when it comes to how many of us live worldwide in rural. Don't forget them, because obviously we can have satellite systems if none of the other communication technologies that I've mentioned so far work nicely. You can have what's called, so you might be familiar with LEO, for example, as low orbit satellites, but these ones can be very low. So even in waters, having sensors or communicating to satellite, back to petroleum units, so all of that is good. And farm, so for example, we've looked a bit on polytunnels, but you can see in a number of, a farm, how drones, for example, can help in identifying and mapping, the crops, for example, in order to improve on the waste and water usage and everything else that comes with that. So within any of these smart environments, whether smart city, farm, rural, water, any of this, is really the technology behind it. So even when we talk about AI, mostly people associated with it in the cloud. More think about it in the devices, more think on-device AI. Think of that distributed really side rather than the centralized bit. Edge computing, I know that I can see some of the computing stuff here with regards to edge computing. I'm sure you would agree as well with all the advantages that come with edge computing. And I'm mostly excited for really having my digital twin working hard. So if you notice, this is me here in the water. I want to be doing this while my digital twin is working very hard in the metaverse. That is my plan. So a lot of exciting areas there, and a lot of exciting opportunities, whether you think in computing, in electronics, and telecoms, and health, and everything that will make this smart. So I can't leave you without mentioning on the STEM side, and it's really a massive. How am I with time? 5 minutes. Okay, I'll rush through the next bits. There is no way that we can't inspire more into higher education. I mean, look at this. It's really heartbreaking to see that, but it's a 6.86. It's like even it's reducing, and that is we're looking at percentage of all the students going into engineering and technology. If you know anyone, family, friends that are thinking, I don't know what I want to do, say engineering, technology, you have to get into here. And this is that one that I was showing you as the first degree. That's where we are at the moment in the UK. So this is a UK engineering report of 2022. And when it comes to gender, we've got less than 1 in 5, so 18.5% of all engineering technology first degree entrants were women in 2020-21, where they account to 56.5% in overall. We do a lot of activities. Again, I'm always very grateful for all the staff and students in everything that we run, whether it's residential, a few days where they come and they experience what it is, or trying to influence the influencers, so influencing teachers, influencing parents, where we run that, for example, we hosted this, and we had a number of workshops and so on in there. And my final thing is still in EDI, but really focusing on race, and that's really the final one that I want to leave you with, is the gap in higher education. So this is awarding attainment gap. As Mike said, when I became the chair of tackling racism, and that was the first thing, I'll just let you read this, I'll probably just read it because of time, but as a student's race and ethnicity can significantly affect their degree outcomes. That gap of Black, Asian, or minority ethnic backgrounds, getting first or upper second is 13%. That was 2017-18, and that was back in May 2019 when that report is done. So as any out there that there are, I can see a number of academics in there, think please on when you are putting out a course, for example, tried with engineering to embed this, and I was successful in a number of things where, for example, where I was showing you earlier with the flood warning part of it, I give a course workout to do the terrain modeling for where is best to put the gateway, for example. That one is very specific, but the terrain modeling in other scenarios, I asked the students to use a map that they most relate to. So it's even small things like that, or journals, conference papers that you are studying and giving out. If you give out from the region that most your students relate to, or if you give a few papers to cover, all of that would really make a difference. The happy note is, I don't know if it's happy, but happier, is that this gap, so between a student that comes from Black, Asian, and minority ethnic to white comparison, so that 13% in the last 3 years have been reduced to 4.4% to 8.8%. So still a lot of work to be done. And it needs all of us, you know, the effort of everyone, but it's really extremely important. So thank you so much. Thank you.
We've got an opportunity for questions. I'll just kick off. Tuleen had more questions from some people, either yourselves or other friends and colleagues who couldn't attend, I think, than we've ever had. So they seem to fall into two broad themes. One was sustainability and one was security, both of which I think may affect the pace of that kind of nirvana that you presented us with. I wondered if you had any observations yourself about those two themes.
Yeah, so when it comes to you know, being greener, for example, so everything that I have mentioned there, whether it is the hardware, the algorithms, they all have to be greener. You know, we're all working towards that. There is what we're introducing, so if you're thinking, oh, it's going to be more electronics, there's going to be more devices, more sensors, more comms. Yeah, but they're all, again, the smarter bit, which is really important. So remember, everything that we are introducing will really work harder when it comes to efficiency, when it comes to really kind of thinking about the environment and be greener. So although it is, you know, it is definitely a concern if you are thinking that we have got more in there, every single bit that is developing is really developing in that in mind.
Okay, and security?
Yeah, security is a massive area now. Again, every stakeholder, I don't know if you had, I think I've mentioned it in the class. I know it wasn't a security bit, but it did sound like it. Did you hear the news of that electric vehicle that was stuck at 30 miles per hour nearby Glasgow? I don't know if you're not. It can sound a bit similar to, you know, something of being compromised in the security. I don't know, it was a happy story, nothing happened to the driver. It was stuck about to 30 miles per hour and the police had to, you know, to do a braking, you know, in a safe way. But the point is that that's the fear of a number of, you know, of everyone, you know, public and everyone. So even the algorithm, for example, that I did show you with regards to the safety messages, the most recent one of that algorithm has an encryption part to it in order to make sure that we are considering, you know, the security side of it. So yes, absolutely massive, and I know it is really a concern for everyone, but all stakeholders work really extremely hard in order to try and minimize the impact as much as possible.
I could sit here all night asking
yes,
questions,
I know.
but I should open it. Does anybody else have a question this evening about either the technology bit, the STEM bit, the EDI bit? Opportunity to, yeah. If you just say who you are and where you're from.
Yeah, thanks for that. CCD, business in Glasgow, I'm a student in college, the GCU and architecture at University. You mentioned digital twins, and that seems quite alien to me, that concept. So I suppose a question would be, how realistic do you think digital twins actually are in the future for work and pleasure at the same time, type of thing? And what timing do you think for that actually becoming a real thing?
Yeah, so what I've given there was just really my hope. It's not the digital twins, obviously, as you know, is mostly really found in scenarios that are different from these scenarios. But if you're thinking even with the metaverse, I mean, we've tried even in the past. There was something called Second Life. I don't know if you remember this. I can see some that they are just smiling in there. It's really a good question. So Demand maybe what would dictate one thing is applications is what would dictate it. There was I was listening this week. There is something called it's part of a Mobile Europe, and they have this called Telecoms Talks. And there was something that was mentioned that I thought, yep, this is exactly right. Apparently, BT said that they have more pilots than BA. And what they meant by that is there is a lot of pilot work that happens all the time. And I think, you know, it could either take, you know, over a number of areas, or not in the way that I've described it. So I don't know about how many years, whether it will happen or not in the context that I've put it, but for sure for other digital twins, you know, especially when we're looking at setups and hardware, and then they are definitely happening from now, you know, for sure, but not in the context that I've put it.
Hello, my name is Terry Francis. I'm here in the MSc for Big Data Technologies.
Yes.
So my question is obviously biased towards the data side. With the expansion of the Internet of Things and the volumes of data that's coming out, the way in which that's going to be broadcast and wirelessly put around, is that going to put massive like a chokehold on all of the wireless communications at the moment? And secondly, how do you look at the ethical side of using the data which is predominantly around, particularly in relation to the BAME, so that you can make sure that everyone has fair use of the data which is available?
So really two good questions. I think if I take the first one, if we've got more on the device and the edge, if you have the idea of the distributed intelligence and more AI, then really what should happen is that it should act like a filter. So for example, if you are, let's say the flood warning, the one that I was mentioning, if you have a sensor that is detecting data and you are asking it to do that constantly, and there is no change in that, then that should really, at that end, at that node side, should really be filtered. So you are only transmitting and using, you know, the channels for what is important to transmit.
Yeah.
And that's what you're told the on-device AI would be really doing.
That makes sense. So that would be the difference in, say, things like Siri and Alexa. So apparently Siri keeps a lot of the information internal. It doesn't just bash everything off to a server, which will mean it's going to reduce how much communication it needs to make to the server.
Exactly, and then going back to how energy efficient things would be, that wouldn't be the most energy efficient to be obviously always transmitting unless there is something that needs to be transmitted.
Data on demand.
Yes, exactly, yes.
Thank you.
My name is Nadia. I'm an aerospace engineer. I'm pursuing the cybersecurity profession. Thank you very much for the lecture. I have two questions. One of them is the ethical consideration for the white noise that is going to be generated by this kind of communication. The second one is that regarding the vehicle-to-vehicle communication, do the vehicles have the intelligence to make, to take the decision making? Is it happening in the vehicles, or is it, from like a remote server?
So it's both. They do have, and there is as well to the servers. So you wouldn't believe how many hundreds of sensors each of these vehicles now these days have. And a lot, again, going back to the point of having that intelligence to filter out as much as possible, but there are ones that they are critical to, for example, imminent collision or any safety massive things. So, yeah, for sure, it's both ways. So it's intelligence in the car, filtering as much, but also communicating back I wouldn't say to the server, it's usually via the core network and the infrastructure rather than going back all the way to server, unless it's something like I've mentioned with the messages and there with the safety messages server that needs to make some comparison. Your other question on the noise side, then, yeah, I mean, there's always the fear that more that we are adding, it goes back, for example, to are we becoming, you know, more when it comes to sustainability and not being so green and everything else. But we're really getting better in what we are producing, whether it is the hardware side, the software side. So although you're right, it could, but it's how much we are doing things much more you know, smarter, basically, what I might be the smart with.
Thank you very much.
Hi, so my name's Christine Horrocks. I've just taken over Dean of School for a while, but I'm a psychologist, so I kind of watch with interest what you're talking about. So I remember a long time ago talking about to students and teaching them about how we're going to become cyborgs in the future, part human, part machine. And I watched with interest the whole kind of hardware and the functioning of the network that you presented. But to what extent do you integrate people into that system you create? To what extent are persons accommodated and intrigued by? And you know, you talk about people being resistant to kind of automated vehicles. I kind of love this kind of stuff, but I know I'm unusual in my friends. Now, is that a generational thing? Or do you think there is something more fundamental about us as human beings and the concept of control, when we're giving our locus of control over to a network? And will there always be a sense of resistance to that as human beings and all the worry we've got with AI? I suppose my question to you is, how does this progress work and without the person being somewhat integrated?
I think person is essential to it. So I really all really spot on points there, Christine. So even when we say smarter, if the person is not, how much you said would be integrated, anything at the moment that is around us, if you go to a smart parking space, if you as the driver not willing to integrate with all the messages you're getting, the sensors information you're getting in order for you to park, then that would not happen. So it is really integral to anything that we have mentioned, how much we are willing, one is to really integrate with the technology. And it happened over a lot of years. I mean, how many times have you thought from the 90s, with the phones coming, first we thought, okay, oh, that's great, you're just phoning someone, oh, you can message someone 160, characters. I think we have accepted, I would say. I know AI is a little bit different just because at the moment there is a lot of stories, I think a lot of people that are scared of what it will bring rather than seeing it that it will assist them in their daily life. So I think it's a combination, but I'm almost sure even if you look at now, there will be, it's not a generation thing, but there will be some people that it will be very divisive. Some will think, yes, I am going definitely to go with all the new technology opportunities that it brings, and others will say, no, I'm happy with what I've got and I'm happy where I am.
But I watched your presentation, it was wonderful to watch. I thought, gosh, I didn't really understand all this, but this looks great. But I'm intrigued by to what extent, because you get quite a significant amount of research income that you've generated, to what extent of people being at the centre of that? I wonder.
So it's a very good question because my aim would be automation. My aim is to take out at the end, that, but the idea is really to serve people better. So if you look at early warning, flood warning, and the idea is fully automated, it's intelligent, it will give you the best. You'll get a message, you're sitting in this area, so you must be in an area that is experiencing some changes, you know, with the nearby river, for example. It is to serve people, and we automate, we get more into the intelligence to make our life better, to make our life more enjoyable as well. So not only with disaster stuff, but to not enjoy just saying, Alexa, do this to me.
I think that's a topic of conversation for a glass of wine, and I think that's about ready now. Thank you very much for your talk. I think everybody enjoyed that today. You are able to join us. There's a reception in the next building. You just go out the doors and hang a left, and there's somebody there to direct you. There's a glass of wine and I'm sure other refreshments to take advantage of. Thank you very much for coming.